So today we'll be talking about arcs, sectors, and segments. When we refer to arcs, we're actually talking about the arc length. The arc length is the distance along the arc of a circle, i.e., basically the distance along the outside of the circle based on the angle of the circle. In essence, we basically have this equation. And for this equation, this represents the fraction of the circle in degrees, using degrees. And then this portion here represents the circumference of a whole circle. So basically what we're doing is finding out how much of the entire circle, how much of the pie we actually use. We change that into a percentage, which is what this fraction represents. This represents a fraction, a percentage, as a decimal of the circle based on its degree. And then we multiply by the circumference to actually get the actual length that's actually been traversed along that circle. As usual, we'll start with a dot in the center and then we'll draw our arc. So the arc is actually the distance along here. And then this is our angle theta, just like before. And this is important. We have to know what the radius of our circle is. So in order to get the arc length, you need to know the radius and you need to know the angle that is swept by the arc, at which point we just calculate the arc normally. When we're talking about the sector, we're actually talking about kind of like a piece of a pie again. If you think about it, we have our central angle, just like before, but this time what we're actually calculating is not how far we've gone along the outside of the circle, but this time what we're figuring out is we think of this as the full area created by the central angle, i.e., basically, I need to know what the area of the slice is based on the angle that's been used. Just like before, this represents the fraction of the circle. And this portion represents the full area of the circle. So now, when we're talking about the segment, we're actually going to have something similar to this. So we're going to start with our central angle as well. Then we're going to draw basically what we had before with the sector. But instead of taking the entire wedge like we did last time, this time we're going to take a chord directly across from point A to B on here. And then what we're going to do is we're going to calculate the area right in this blue section right here. So when you hear about the idea of a segment, we're talking about the area between the chord, which is here, and the arc. That's all we're doing. Oh, I forgot to actually label where theta is. Theta is the angle here. And this is going to be R, and also this will be R for our sector. I expect you to memorize all three equations: the arc length, the area of a sector, and the area of the segment. Now, basically we're just going to do some basic calculations using our equations. Okay? Now, you'll need to memorize the arc length, the sector, and the segment calculations in order to do these problems. First problem says to determine the arc length of a circle with radius 8 meters and central angle of 110 degrees. We start by setting up our basic equation. And now we do the appropriate substitution. And now we do our final calculation. Don't forget to use their brackets. Now when doing calculations for me in this course, only go to one decimal place. You will get all your marks in these spots for these questions. 1 for the equation, 1 for the substitution, 1 for the appropriate number, and 1 for the appropriate measurement. And that's it. Now, let's do B. A circle has a radius of 12 centimeters. The central angle of the sector of this circle is 52 degrees. Calculate the area of the sector. Just like before, you're going to get 1 mark for actually setting up the equation. Boom, 1 mark. The next mark you'll get is for setting up the appropriate substitutions. And there we go. And our final answer is 65.3 centimeters squared with the appropriate check marks. So now we're going to deal with a diameter of 8 inches, and we're going to determine the area of the segment with a central angle of 62.5 degrees. Remember that the segment was always the most difficult one. We're going to start off with 1/2 r squared bracket pi over 180 theta minus sine theta end bracket. As usual, 1 mark for the equation. 1 mark for the appropriate substitution. Remember, we said the diameter was 8 centimeters, so r actually has to be 4. And then we'll substitute accordingly. And 2 marks for your final answer, which is equal to 1.6 inches squared. This next equation requires you to do some solving for either r or theta. So let's just go over this. What is the radius of a circle that has an arc length of 15.3 centimeters and a central angle of 102 degrees? You'll clearly get a mark just for the equation. Now we're going to do the substitutions, and then we'll figure out which variable we have to solve for. In this case, we've got 15.3 is equal to 102 divided by 360 times 2 pi, r. We don't know what r is. Now, seeing as that we have 102 over 360 and 2 pi r, it's all combined by multiplication. So what we can do is we can literally take 102 divided by 360 and multiply by 2 and times it by pi, and we will get what all of this is equal to. In this case, when I punch it into my calculator, we find that this is equal to 1.78, and what we have left is r on the right side. So now we have 15.3 on the left side. In order to move this 17.8 to the one side, we don't subtract it or add it. We actually have to divide it because that's the opposite of the timesing that's happening between the R and the 1.78. So we have R equaling 15.3 divided by 1.78. And just like I said,